Okay, Assalamualaikum warahmatullahi taala wabarakatuh. Good morning.
Good morning, Doctor.
Ohayou gozaimasu. Morning, guys.
Morning, Doctor.
Good morning, Doctor.
Morning, Doctor.
Good morning. Itu je? Tiga orang je yang good morning. Yang lain?
Good morning, Doctor.
Selamat pagi. Good morning. Ceria lah sikit. Pagi-pagi ni.
Morning, Doctor.
Morning. Alright. Semua apa khabar? How's everyone?
Doing fine.
So
You're
far,
doing
so
fine.
good.
So far, so good. Can any one of you can speak Japanese here? Do you speak Japanese? Any simple Japanese? Saya nampak ada orang. Saya nampak ada orang tulis kat situ. Ohayou gozaimasu kat situ kan. So I guess that maybe some of you can speak Japanese here.
Skoshi.
Skoshi ne. What does it mean by skoshi, minasan? Everyone? Apa maksud skoshi?
A little.
A little, yeah. Skoshi ne. Any Japanese words you want to share with me? There must be fans of animations, right? Japanese anime. Siapa suka tengok anime? Tak ada?
Used to
Used to.
be, now no time.
Siapa?
Saya.
Long time. Give me some titles. Apa episodes ataupun animation yang you suka tengok? Anime apa yang you tengok?
Attack on Titan.
Titan ya. Lagi?
Juga.
Sama juga. Lagi?
Full Metal
Assassin's
Alchemist.
Classroom.
Wah, banyak ni. Okay. Any dramas you've watched before? Apart from animation? You watch films? Or you like anime more than dramas?
Anime better.
Both.
Anime is more fun, yeah? Interesting. Okay, do you have any words that you really like? Any Japanese words? Or maybe words that you don't understand, you want to know what it means, and that's it. Ada tak apa-apa perkataan yang you rasa, saya suka perkataan ni? Anything? Maybe you watch them from a movie, maybe from anime, that's, you know, you kind of like them. Ada tak apa-apa perkataan yang you suka? Yang kita boleh share kat sini? Cuba sebut sikit. Saya nak dengar.
Sugoi desu ne.
Wah, sugoi desu ne. Sugoi means? What does it mean by sugoi? Kalau dalam bahasa Melayu ataupun in Malaysia kita sebut macam hebatnya, terrornya, macam itulah. Sugoi desu ne. Sugoi ne. Lagi? Kalau saya nak kata, wah, you ni terror lah, you ni hebat lah, you're cool, super cool. Macam nak cakap?
Jiozu.
Awak apa macam nak cakap? You, what is you in Japanese?
Anata.
Anata, okay. Other than anata, apa lagi perkataan you boleh gunakan? Anata is more like awak. Kalau you nak kata, if you want to say kau ni hebat lah. It's more like you're closer, you know. When you're closer to that person, then you can use kimi ataupun or you can say omae. Tapi dia kasar sikit lah. It's more like if you're not close to them, then you don't say omae. Then you just say anata, awak. So you can say anata sugoi ne, kimi wa sugoi ne, omae sugoi. That's how you say it. Ataupun kalau you nak kata you ni cute lah, macam nak cakap you ni cute. What is cute in
Kawaii.
kawaii? Okay guys, can you say it? Kawaii.
Kawaii.
Kawaii. Kawaii.
Okay.
Kawaii.
All right. Okay, I think it's more like close to Mandarin, right? Kalau Mandarin sebut apa? Ke ya. Macam mana cakap sebut?
可爱.
Ke-ai. Oh, sorry. Ke-ai. Okay, so in Japanese we call it kawaii. But selalunya in kawaii ni untuk budak perempuan lah. Jarang nak gunakan. We don't normally use kawaii for men or boys. Maybe for little things ataupun animals and yes. Tapi kalau untuk lelaki, normally kalau you kata lelaki tu kawaii tu macam something is wrong. Okay, anything else? Any other words? Maybe before we start our class, I think we should do some. Yalah, nak bagi you mood sikit kan. Saya pun kita terus masuk dalam lecture nanti bosan kan. So maybe I could, advise you some useful expressions. Maybe you nak tahu. Maybe let's say macam ni nak cakap very sorry. Macam nak cakap?
Gomenasai.
Gomenasai, okay. I'm so sorry. Okay, gomenasai is an expression that
Demo.
you use. Demo, what's that? Again. I'm so sorry. Apa dia in Japanese? Tadi ada seorang sebut tadi.
Demo. Demo gomenasai.
Oh, okay. Demo means tetapi, but. Yeah. Kalau you nak kata just I'm very sorry, then you boleh sebut gomenne ataupun gomenasai is very polite way of saying I'm sorry. Kalau you macam kawan-kawan kita
Hontoni ke?
Hontoni gomennasai. Normally kita akan sebut betul-betul saya minta maaf. So polite way hontoni gomennasai. Tapi kalau macam you dengan kawan-kawan yang dah rapat, sorry macam tu lah. I'm so sorry. Macam tu, you tak perlu sebut nasai. You just say, gomenne. That ne tu sebenarnya macam dalam bahasa Melayu, sorry that. So kalau if you add ne, something is after a word, then it becomes more colloquial. Lebih macam conversational. Kalau you tak sebut nene tu, dia macam a bit formal in everyday, in daily conversation. So kalau you nak kata, terima kasih thank you terima kasih then you say, arigato ne. Instead of just say, arigato. Macam tu. So kalau you nak kata, oh sorry sangat, so you say, gomenne, gomennasai, gomenne. I normally use gomenne. Or you can also say, I normally say gomen. I just say gomen. And then I'll just do like this, gomenne, something like that. Okay, is that okay? So do you want to start? Shall we start our biosensor technology? I can always go back to Japanese, I don't mind. You ready? Shall we start?
Okay.
All right.
Yes, doctor.
Okay, thank you guys. So today's topic is electroanalytical techniques. So the other day we had the principle of electrochemistry. Do you guys remember what we did last time? Electrochemistry, it's about electrons transfer. We talked about oxidation, reduction process. We talked about redox reaction. Yeah, what does it mean by redox reaction? Having two processes, both oxidation and reduction at the same time in one system. And then we also talked about oxidation number. What does it mean by oxidation number? Oxidation number is used to show what? Well, why do we need an oxidation number for? If you remember? Kalau you ingat lagi? Kenapa kita kena ada? Why do we have to assign an oxidation number? To show what? And anyone? I think you've done this. Kita dah buatkan hari itu kan? Anyone? I'd like to hear some voices. Seorang dua pun okay lah. At least I'm not bored here. I'm just talking to myself. Okay, volunteer. Come on, we're having fun. I just want this class to be merry. You know, tak lah boring sangat nanti. Oxidation number, guys. Oxidation number.
To know whether the compound gain or lose electrons.
Great. Okay, we want to know whether that molecule or that ion, whatever you are looking at, is donating or is it receiving electrons. So by assigning an oxidation number, we know that whether it is undergoing a reduction or an oxidation process. Okay, that's great. So so today, electroanalytical techniques. We continue with our lecture. Can you see the screen better than that last time? I hope you can see the whole screen. Nampak?
Yes, doctor.
Okay. What is how do you say can you see it in Japanese? Miemasu ka? Minasan miemasu ka?
Hi.
Okay, miemasu ne. Hai. Okay. So, in biosensor technology, we are focusing on voltammetric technique. So the voltammetric technique is the one electroanalytical technique that we will use in our lab, in our experiments. I think this week is week 7, isn't it? So we have week 8, and then you have semester break. And then after you come back from that semester break, we will have a lab session. Betul tak? Ke salah? Betul? Betul ke salah? Am I right?
Yes, doctor.
Betul eh? Okay, always correct me if I'm wrong. Okay. Then, okay. As an introduction to electroanalytical technique, okay, electroanalytical method or technique is in analytical chemistry. It's a study of an analyte. An analyte could be your target molecule, anything that you want to sense, anything that you want to detect by doing what? By measuring the potential. You're measuring the potential, or you can always measure the current. This is the signals that you will get in electroanalytical techniques in an electrochemical cell containing the analyte. So again, I said your analyte is the thing that you want to look at, the thing that you want to detect. Yeah, the sensing material, sensing element, or sensing the target molecule. So there are 3 modes of electroanalytical technique. The first one is potentiometric. The second one is a coulometric. The third one is what we call amperometric and voltammetric. So the first one, potentiometric. But in potentiometry, what we measure is the potential. So potential is measured in what units? Volt. Yeah. And then the second technique is called coulometric. We measure current. What is the unit for current? Ampere. Amps. So we just say amps. Let's say 1 ampere, 2 amps, 3 amps. Yeah. Over time. The third one that we will use, that we want to focus here, is amperometric and voltammetric. Actually, they are similar but different in some aspects. But in amperometry and voltammetry, they both measure current. Yeah. So that is the overview of the 3 different modes of electroanalytical techniques. Right. Okay. This is a history, some overview on amperometric and voltammetry. I'm not sure if you've done, you've had your analytical chemistry, right? Analytical chemistry dengan jabatan kimia ke? Betul tak?
Yes, doctor.
Ada tak you all belajar masa tahun berapa
Second year.
Second year.
Yep.
Apa teknik yang you belajar?
Serial dilution, filtration.
Serial dilution. Lagi ada teknik lain? FTIR ke, NMR ke, I don't know. Ada tak electrochemistry kat situ?
During analytical chemistry, we used FTIR.
FTIR. Oh, okay. Then, so you haven't done any of this? Amperometric, voltammetric, tak pernah dengar? Pernah dengar ke? Tak pernah. Tak ada,
Macam pernah, doctor.
Macam pernah, but not that detailed.
Not that clear.
Okay, no problem then. Okay, jangan risau Okay guys, don't worry about too much about this. It's just a technique. Yeah, everyone can study. Not just chemists use this. Even biologists, even engineers use this technique. Yeah, so this is just another technique that is very useful in detection or sensing. So let's say let's have a look at amperometry. Amperometry is about measuring currents over time. Remember, and then chronoamperometry. If you look at the word chrono means time. So in chronoamperometry, you measure the current and then you fix the potential. Potential means we look at potential as something like an energy, electrical energy that you impose on the system so that it will give you a signal. So let's say you fix the potential at 0.8 volts. Yeah. Kalau you guys ingat lagi the very famous equation, V is equal to IR. Voltage is equal, volt is equal to what is I? Current multiplied by resistance. So this is applicable in electrochemistry. You will use the same equation. Yeah, sama je. So in chronoamperometry, you carried out or you perform or you do the experiments in unstirred solution. You don't use a mixer, you don't use a stirrer to mix the solution. No stirrer. Okay, at a fixed electrode. Okay. Okay, then we look at voltammetry. Voltammetry is just a subclass of amperometry. It goes under the class of amperometry, in which the current is measured at varying potential. So that means you don't fix the potential. In chronoamperometry, you fix the potential. That says your potential is 0.5 volts. But in voltammetry, you don't fix it. Let's say you select a range of potential. Let's say from minus 0.5 volts up to 0.5 volts. So there is a minus and there is positive side of the voltage. So that is what we call range. Or in electrochemistry, that range is what we call potential window. Ya, kalau saya kata, okay, apa potential window ni untuk voltammetry? So what I meant by that is that saya nak tahu range yang kamu akan range voltage yang kamu akan kenakan kepada sistem you. So you can say, okay, I do the voltammetry, the window potential window from minus 0.1 up to plus 0.1 volts. So that is your window. That is your potential window. In voltammetry, there are different types of voltammetric techniques. There is a linear voltammetry, which is LSV. There is a cyclic voltammetry, CV, which we will use in the lab or in this course. There is a differential pulse voltammetry, DPV, and so on. There are a couple of a few types of voltammetric technique, but we'll just focus on linear and cyclic, especially on cyclic voltammetry. So these techniques will give you different kind of signal or different types of purposes. But They all will give you signals in the form of current, electrical currents. So electrical current means you are measuring the signal in ampere units. Remember, amps. Okay, then the rest of, I think, okay, the most important thing here is analytes. Only a very small amount of the analyte is consumed at the two-dimensional surface of the working and auxiliary electrode. Auxiliary electrode can also be called, what do you call that? In voltammetry, there are three different electrodes. One is working, the other one is reference electrode, the other one is auxiliary electrode. So we'll show you the picture of how it looks like in the next slide. And then there is a term there, polarography, polarization. What does it mean by polarography? I've sent you a link, video on YouTube. You can always watch that. But in the bottom line there, yang paling penting untuk kita tahu tentang polarography, it's about you are imposing a electrical force, voltage, you're applying a voltage to a solution. Then that will cause the solution reaction from that, and then you will get your signals. That's what we call polarization. Okay, in voltammetric technique, we will have electrodes, and then we will have supporting electrolyte. Okay, let's go back to the basics of electrochemistry. If you remember the beaker, we have a beaker, a glass beaker, and then inside it we put a solution, an electrolyte. Electrolyte is something that is conductive. Conductive means it can allow electrons to transfer, or it can allow currents, yeah, to flow within that circuit or that system. So supporting electrolytes normally are salt solution, normally lah, which is conductive, yeah. So electrodes, there are three. I said to you, reference electrode. Okay, this one here, reference is something like a baseline, something that you can use as a base to measure the potential. Then you have a working electrode. This is the one electrode that will detect whatever you want to detect, wherever you want to sense. So this is the one. Or if you remember, you've done immobilization technique, you've done sensing elements. So this is the working electrode on top of the surface that which you will immobilize whatever sensing elements there. So in electroanalytical technique, in voltammetric technique, we are focusing on whatever happens on the surface of the electrode. If we don't get interactions, if we don't get reactions to occur on the surface, then you will get no signals. So that is why it is very important for us to know the best way to immobilize your sensing materials, and then only then you will get signals in the form of electrical currents. So the other electrode here is the counter electrode. The counter electrode is used to minimize the noise. So whatever reaction is happening is being recorded between reference and the working electrode. The noise from there will be suppressed by the counter electrode. So the counter electrode is not directly terlibat. It doesn't involve in the reaction, but it just helps in removing all the noises. So that's the roles of each one electrode in the system. Okay, so I think that's pretty everything that I've said about the three electrodes. And the beaker here is what we call cell. Now, whatever glass beaker, it could be in a heart shape, it could be just a normal beaker, but whatever you use is what we call cell. So we call it an voltammetric cell, something like that. Yeah. Then Right. Okay, in photometric technique, one of the most important electrode is reference. The most basic reference electrode is hydrogen electrode. Remember, because standard condition, the reduction potential is 0. Then that is why we use it as a reference. But there are also other types of electrodes that are popular. We normally use a saturated calomel. There is just a normal calomel. There is a silver chloride electrode. There is a mercury sulfate electrode reference. But they are all reference. They are not involved in the reaction directly. They are the reference. Yeah. Okay. Then we move on to the working electrode. So the working electrode is the one that we will have to focus more, because this is the electrode that will give you signals. So whatever you place, whatever you immobilize, whatever you attach on the surface of your working electrode will give you signals. It will give you signal only if there is an interaction between the sensing material with your target molecules. So let's say if you want to detect DNA molecule, then your DNA molecule has to interact with your whatever probe or sensing material you put on the surface. Then the reaction happens. From that reaction, there must be an electron transfer. Remember, electrochemistry is all about electron transfer. So if there is no electron transfer, there is no current. Okay. Up to now, is everything okay? Semua okay kat sini?
Okay.
You guys okay? Yeah. Okay. What is the definition of current? Ingat tak? You guys ingat tak? What is the definition of current? Kalau orang tanya, arus elektrik tu apa? Ah? What is current? What is the relationship between current and electrochemistry and biosensing? Kenapa penting saya nak faham konsep ni? You must understand the concept so that you tak perlu nak hafal banyak-banyak. If you know the concept, then it's very easy. Okay, electrical current is defined as the number of electrons flowing in 1 second. Okay, again, I said electrical current is defined as the number of electrons flowing in the system within 1 second. For every 1 second, how many electrons are transferring? How many electrons are running? How many electrons are moving in the system? So if there are more electrons flowing, that means the bigger current that you will get. So if there is no interaction, if there is no reaction taking place, then you will get no signal or less signal. So your signals is proportional to the number of electrons produced in the reaction of whatever you are looking at. Yeah. So it's very important for you to check, to determine, to fix, to decide which types of and sensing elements that you want to immobilize on the surface. So the surface, the act of modifying the surface of the electrode is called surface modification. Yeah, when you immobilize something on the surface, normally the surface is it could be is made of plastic carbon. It could be gold. You could also have a platinum electrode. You could also have a mercury electrode. So on that metal surface, you immobilize your sensing elements. So every single one working electrode has its own potential range. That means, maksudnya, if you impose more than whatever it can withstand, maksudnya, let's say if you look at platinum electrode. Okay, kalau you nampak kat situ warna merah kat situ, range dia adalah in between minus 0.4 up to about 0 plus 0.7. Kalau you impose electrical potential of, let's say, minus 0.7 di luar range yang dia boleh tahan, then you will damage your electrode. So once you damage your electrode, you will not get an accurate signals, accurate data. So you tak nak tu. That's why we have to know the right potential window for each working electrode that you want to use. Okay, itu sebagai overview lah. These are the some of the advantages of control potential techniques. When we say control potential technique means either you fix the potential, or either you fix the time, or either you fix the parameters. So voltammetry, amperometry, potentiometry, they are all good because these are the advantages. They are the good things about them. The number one is it's coming from its sensitivity. It shows a high sensitivity. Kalau you guys remember, how do we define sensitivity? Let's say you get the sensitive. The sensor is very sensitive. What do you mean by sensitive? Anyone? Ada siapa-siapa nak share dengan saya, with the rest of us? Saya rasa macam dekat saya kering lah. Okay guys, help me. I need a break. 1 minute break. Saya nak dengar seorang cakap pasal sensitivity. It's just an idea, okay? There is no such thing as right and wrong. Kita belajar. So I hope that in my class, you don't mind talking. You don't mind speaking out. Yeah, speak up, whatever it's in your mind. Belajar supaya kita lebih senang untuk bagi opinion kan. Jangan malu sangat, takut salah lah. So if you keep doing that, then nanti you akan bawa you punya personality tu sampai you kerja. It's okay to be polite, it's okay to be reserved, but sometimes we have to cakap kan. So when it comes to the time where you need to talk, kita cakap. Boleh tak? So I need someone to say something about sensitivity. What does it mean by sensitivity? Anyone? Siapa?
Is it about able to detect something?
The ability to detect something at, let's say, kalau macam ni tahu dia sensitif ke tidak?
A very small amount of sample is enough to give the result.
Yes, even though you have very small amount of pollutant, let's say, katakan ada sedikit E. coli dekat dalam you punya air, walaupun E. coli tu dia punya concentration is just about nanomolar, you masih boleh detect dia, saya masih boleh mengesan dia, then it is very sensitive. Tapi kalau sensor, biosensor yang you ada ni, kalau dikata paling minimum kita boleh limit dia adalah micromolar. Maksudnya kalau nanomolar dia tak boleh detect lah sebab sensitivity dia kurang daripada yang sepatutnya yang sampel yang you ada. Okay, that is sensitivity. What about selectivity? Kalau selective macam mana? The biosensor is not selective. Kalau tak selective ni bagus ke tak bagus? Is it a good thing or not a good thing? Bagus ke tak bagus kalau tak selective?
Depends on what we are going to measure.
Okay, let's say you ada satu memang, I just want the biosensor to focus on one target molecule. Then you want selectivity, right?
Yes.
Okay, that's good. Okay, then we have versatility. Yang tadi baca dah sikit tentang versatility tu, and then it's portable, Speciation, capability, ini pun nanti boleh baca sendiri. But the most important thing here, number 6, I think it's quite a very useful information. A wide range of electrodes that allow access of an unusual environments. Selalunya kita gunakan teknik electroanalytical technique ni untuk measure anything that is related to pollutants of the environment, yeah, environmental pollutants. Okay, this is the screen that you are looking at is talking about the sensitivity, the detection limit. So when we say nanti, I think the last chapter will be covered by Dr. Shafinas. She will be talking to you about the performance, how you measure the performance of a biosensor. So when we say performance, we mean how sensitive, how selective. So sensitivity is always about detection limits. Ya, kalau you tengok dekat sini, let's say DC polarography. This is just a technique. Limit dia adalah 10 to the power of minus 5. Maksudnya kalau you ada lesser than that, concentration of your target molecules is lesser than 10 to the power of minus 5, then it won't be able to detect. Maksudnya tak boleh nak kesan. Let's say kalau you tengok cyclic voltammetry. Okay, we have cyclic voltammetry here. The detection limits is about 10 micromolar. Micromolar. Kat sini dia tulis itu. 10 to the power of minus 5 is equivalent to 10 micromolar. Okay, and the rest goes on. Ada stripping voltammetry. Dia lebih sensitif lah. So it depends on the concentration of the target molecule. You choose which types of voltammetric technique that you want to use. Whether it's stripping, let's say absorptive stripping will give you more sensitivity. Let's say 10 to the power of minus 10. Absorptive, the other one in solid form is 10 nanomolar. The other one is absorptive catalytic stripping voltammetry, 10 to the power minus 12. So it's just about how sensitive this technique can be. Okay, right. So here, if you remember the Faraday process, do you remember what was the last one of the last slides in the previous lecture in the principle of electrochemistry? Remember? Voltaic, what was that? Remember that? You have those in the beaker, there's 2 electrodes there. The reaction takes place spontaneously, and then you call it, what is it? Voltaic what? Anyone can recall? Baru je hari itu kita buat. A system that can generate power or apa kita panggil work, can do work, release energy. Anything that is happening spontaneously, kita panggil apa? Guys? What cell is that? Voltaic cell.
Yeah,
Tak dengar lah. Apa nama dia? Sebut lagi sekali.
Voltaic cell.
Voltaic cell. Okay, this is similar in the Faraday process. Faraday current is the current generated or produced from what? By the reduction or oxidation of whatever chemical substance at the electrode. So whatever is the sum, the overall sum of the Faraday currents will give you a signal. That signal is your current. Yeah. So okay, reactions is controlled. Reactions are controlled by mass transport. So let's say you have something in the cell, in a beaker, and then you have your electrode here. Let's say this is the surface of your electrode. There's a pen, and then you immobilize something here. You put your sensing material on the electrode, and then you put it in a beaker, yeah, something like this, and you turn it upside down like this. So whatever reaction in order for the reaction to take place, your target molecule inside the beaker, inside the cell, must travel up to the surface of your electrode. Kalau you punya, if they don't travel, if you don't transfer, you tak akan dapat interaction. If you don't get interaction, there will be no reaction. No reaction means no currents, no electrons will be produced. Right? So that is the concept. So a lot of what is that? In voltammetry, the most important thing is for the target molecule to transport to the surface of the electrode. The act of transporting is what we call mass transport. Either it's in ions or any molecules, we call it mass transport. So reactions are also controlled by the rate of electron transfer. Okay, how fast can the electron is being transferred? Remember reaction rates when you do fermentation, let's say, you have to know the rate determining step. The one that is the slowest step will determine the overall reaction rate. So it's the same as in voltammetry. If your electron transfer rate is very slow, then that step is what we call determining step. That will determine your reaction rate, how fast electron is being transferred. Okay, so Faraday process is about oxidation and reduction, and you have electron. That reaction will occur in a potential region that makes the electron transfer thermodynamically or kinetically favorable. Okay, just focus on the electron transfer. So there is a Nernst equation here. The same is, remember we had a Nernst equation in our first lecture. So we use Nernst equation when your reaction condition is not in a standard condition. Remember, standard condition is defined as temperature at 25 degrees Celsius and pressure 1 atm. So let's say if you do it in a room, in the experiment, in let's say in a lab, the room temperature is 27. Then it is not standard. So you have to use this equation, Nernst equation. Yeah. Okay. The Faraday current is a direct measure of the rate of the redox reaction. Remember, in electrochemistry, there is a redox reaction. That means something is being oxidized at the same time something is being reduced, because let's say here there is an oxidation. Oxidation means you're producing electron. That electron is being transferred through external wire. It goes to the other electrode. Let's say this is anode, this is cathode. Now cathode is receiving one electron. Then there is a reduction here because it is receiving electron. So that is why we call it redox. Yeah. So the signal, the graph that you get from voltammetric technique is called voltammogram. So nama dia lah, nama graph yang you dapat tu, we call it voltammogram. So in voltammogram, you are measuring currents, which is the y-axis, and then you fix your potential window, the voltage. So current versus voltage. That's the voltammogram. Okay, the electrode reaction was whatever happens at the surface of the electrode may involve a couple of steps, and the rate of such reactions is determined by the slowest step in the sequence. Ini saya dah sebut tadi. It depends on what is the determining step. Let's say whether it is mass transport, macam mana your target molecules is being transported, ataupun it's how it moves, how fast it moves to the surface of your electrode. Okay, simple electric reactions may involve only, could be three. One, mass transport of the electroactive species to the electrode surface. Number two, electron transfer across the interface. Interface means there's a liquid and there is a solid. Solid is your electrode. Electrolyte is in liquid phase. So interface means yang kat boundary itu kan. Kat situ when we have a different phase of mass ataupun you know, they have a liquid and solid, for the electron to transfer between these two different phases akan ada friction ataupun ada resistance kan, sebab dia tak sama phase. Jadi kat situ akan maybe will give some effect on how fast your electron can be transferred. Or it could be coming from the transport of the product back to the bulk solution. Bulk solution maksudnya dalam inside this inside the cell, dalam air, dalam liquid yang you ada dalam cell. Okay, so more complex reactions include additional chemical and surface processes that either precede or follow the actual electron transfer. Right, okay, we'll move on to the next slide. Okay, seperti yang saya sebut tadi, as I said just now, the mass transport, there are three types of mass transport. Ada tiga cara macam mana you boleh, macam mana you punya target molecules can travel up to the surface of an electrode. Okay, one, diffusion. Okay, siapa tahu what is diffusion? You all perasan tak kalau you buat, let's say you nak buat air Milo kan, first thing you buat apa dulu? Betul tak saya nak tanya macam mana you buat air Milo? Anyone? Puasa ni buat air Milo lah pula. Anyone? Macam mana buat air Milo? Milo apa? Milo kosong lah, tak ada susu, tetap gula je. Okay, macam mana cara you buat?
Boil water first.
Okay, get a hot water inside a cup or anything. Lepas tu, what do you do then? Lepas tu buat apa?
Pour the powder.
Okay, you pour in the powder. Lepas tu, adakah you akan biar saja?
Stir.
You stir it. Kalau kita tak stir boleh tak? Kalau kita tak kacau dia. Boleh tak? Can we still make Milo tanpa mengacau dengan sudu ke? Boleh tak?
Can, but very slow.
Okay, betul. Okay, that's the point there. So, that's diffusion. Kalau you letak sebuah Milo the Milo powder inside your cup or apa sajalah cawan ke apa, kalau you biar je, you masih akan dapat air Milo, tapi dia lambat kan. So that process of proses Milo tu merebak ke seluruh dalam cawan tu dinamakan diffusion. Okay, diffusion comes from concentration gradient. Maksudnya from a more concentrated area to the less concentrated area. So the spontaneous movement, sebab diffusion is spontaneous, tapi you tak payah kacau, tapi dia cuma lambat sikit, betul kan? So that is what we call diffusion. So the spontaneous movement under the influence of concentration gradients from the region of high concentration to the lower one is aimed at minimizing the concentration differences. Betul maksudnya sebab apa you punya Milo molecule tu ataupun Milo powder tu dia merebak ke seluruh dalam cawan tu sebab dia nak minimizekan concentration differences. So sebab tu dia akan penuh dalam cawan tu lah sekali dia akan dapat homogenize. So that's diffusion. Tapi kalau you gunakan cawan atau you gunakan sudu, if you use a spoon to stir it, then that is what we call convection. Yeah, a convection is about the transportation to the electrode by a gross physical movement. Remember physical movement? Kalau you buat experiment, in any experiment, if you use a stirrer, that is what we call convection. Sebab you nak cepatkan proses whatever you're trying to do. So the major driving force for convection is an external mechanical energy associated with stirring ataupun rotating, whatever you use lah untuk bagi dia kacau dia tu, itulah dipanggil convection. And there's another way of mass transport, which is migration. Migration it's about movement of charged particles along an electrical field. Kalau you bagi electrical field, bagi contoh you letak magnet ke apa kan, in between. Let's say this is your cell. You put a magnetic field here, then automatic you punya ions kat dalam beaker tu akan, the way its stage will berubah. Dia akan lari sana lari sini, it will align. Dia akan lari, jadi kat situ you bagi electrical field. So that's what we call migration. Okay, mass transport by diffusion occurs. It happens due to the uneven concentrations of reagents, where entropic forces act to smooth out these uneven distributions of concentration. Sebab ada tempat yang cair, ada tempat yang pekat, so yang pekat tu akan pergi ke cair. So that's just to minimize the differences. Yeah. And this is a fixed law. Actually, fixed law ni just want to say something about diffusion theory lah. Tak perlulah nak tahu sampai level derivation ni, tapi it's just when we're doing diffusion, kita kena tahu sikit lah tentang fixed law. Nanti you baca sendiri. I don't want to talk about this. It's just additional information. Yeah. Examples of application of voltammetric analysis. Untuk apa? Macam mana you boleh apply voltammetric technique ni? Untuk apa? Okay. Electrochemical monitoring of environmental pollutants. Sebab apa kita gunakan dalam detection of environmental pollutants? Sebab this technique is sensitive, it is selective, and it is economic. Okay, pollutants yang macam mana? What types of pollutants can you actually sense ataupun can you actually detect? Anything that is reducible, anything that is oxidizable can be a candidate to be detected. Syarat dia, you punya molecule tu, your target molecule must be able to be reduced ataupun can be oxidized. Only then it will give you signals. Okay? Why environmental pollutants? Sebab apa kita kisah sangat, why do we care so much about environmental pollutants? Because of the socio-economic consequences. Ada kesan kalau let's say you kata negara kita ni, semua laut di negara kita telah tercemar ataupun sungai-sungai kotor, penuh dengan toksik. Adakah dia akan memberi kesan kepada social dan economic rakyat kita? Of course kan, you all semua dah tak boleh pergi pantai, even sekarang pun apart from COVID-19 let's say masa COVID-19 tak ada kan, we are free to go anywhere, nak mandi-mandi. Of course ada tempat-tempat yang kotor, tapi most of the places kita boleh pergi, boleh mandi, boleh main air, boleh basuh tangan, semua terlongkang kan, yang bersih lah I mean. Kalau kotor, susah kan, ekonomi pun akan terjejas. So environmental pollutants is actually an ever increasing demand. Ada banyak permintaan untuk detect kan, sebab kita sentiasa ada activities yang menyebabkan we produce a lot of pollutants. Macam-macam aktiviti. Cuba bagi saya contoh. What kind of aktiviti yang menghasilkan pencemaran? Ada tak contoh? Bagi saya sikit contoh. Maybe one or two. 例を挙げてください。一つか二つ。dua contoh. 二つください。Please give me two examples. Aktiviti yang menyebabkan pencemaran.
Open burning.
Okay, burning of hutan burning of forest. Lagi? Apa pencemaran yang kita dapat daripada burning?
Air pollution.
Air pollution. Okay, lagi? Lagi satu? What's that? Apa lagi Satu lagi?
Discharge of wastewater from factories.
Factories. Okay, what type of factories? Factory yang macam mana tu? Yang produce apa? What kind of products?
Heavy metal.
Heavy metals. Betul.
Textile industry.
Yes, there's a lot of industry yang menghasilkan banyak pollutants. Contoh, you pergi kedai kereta kan, untuk pergi servis kereta, you rasa minyak kereta yang dia dah pakai tu kadang-kadang dibuang dalam longkang kan, yang dia basuh-basuh kereta you tu, so minyak tu pergi mana? Masuk dekat dalam drainage. Dan lepas tu you dapat blockage kan, lepas tu ikan mati, so that's how it goes macam tu lah. Okay, challenge to analysts. Apa challenge yang ada pada environmental pollutants ni untuk ni? Dia kata ada extremely low concentration. Okay, kadang-kadang kita nak detect, tak dapat detect sebab the concentration was too low. Jadi itu antara challenge lah bila kita nak gunakan teknik ni. Lepas tu ada apa lagi? Complex environmental and biological matrices. Dia kadang-kadang tak semudah tu lah sebab there is a lot of things in, let's say you tengok contoh air yang tercemar, polluted water, you maybe nak tengok, let's say kali nak tengok E. coli saja, tapi sebenarnya dekat dalam sampel tu ada banyak lagi bakteria lain ataupun microbes lain yang interfere, jadi you tak dapat nak bezakan. Itu antara, that's one of the challenges lah. Then large scale monitoring, large structural variability, ini antara cabaran-cabaran dia lah. Okay. Okay, why environmental pollutants? If you look at carcinogens, chemical carcinogens, sebab apa? Carcinogenic is not good to human beings. Sebelum you all masuk FYUP lab kan, you all ada isi satu borang kan? Borang apa tu? Safety lab form ada high rec lah apa benda semua kan. Dia tanya kan, how do we handle chemicals? Dia tanya macam mana, adakah you nak kena bersihkan dengan air ke, you can just wipe it ke, ataupun you boleh guna tangan je ke. Kalau katakan if there is any spillage, then you dah sentuh boleh tak saya gosok-gosok mata. Ada cara kan. So carcinogenic ni boleh menyebabkan cancer. So one of those yang famous lah, molecules yang famous, let's say NPAH, APAH, those with the amines, and nitros, samines, anything that is amino groups, amino compounds biasanya akan memberi effect carcinogenic. And then apart from that, we also have pesticides, we have phenols and phenolic compounds yang kadang-kadang selalulah menyebabkan environmental pollutants. And we also have anti-neoplastic and other drugs that is contributing to the many types of pollutants in the environment. So ini contoh-contoh dia, typical examples of electrochemically active. Remember the keyword is electrochemically active. That means it can be reduced or it can be oxidized. Only then it will produce electrons that can be converted into a signal, which is your current. Remember, this is what we want to stress on. Kita mesti ingat konsep tu. Let's say you tengok There are those in the red boxes and those in the green boxes. So those in red boxes are the functional groups which can be oxidized. So oxidize means you are producing electrons, you are releasing electrons. Okay, and those in the NO2, let me know. NO2, this can be reduced. Reduce means it will accept electron, it will accept what? Protons. Kat situ dia boleh berlaku reduction. And then we talk about carbon-based electrode. The carbon-based electrode, that is the type of working electrode that we will produce in the lab during our lab session in next coming weeks. Because kenapa kita buat carbon-based electrode? Because it's very easy to prepare. It's very can be easily renewed. So the surface, yeah. So once you've done reaction has taken place, you boleh renew the surface ataupun you boleh tukarkan surface dengan anything that you want to immobilize, senang je. And then it has a reasonable potential window. Maksudnya potential window means, and again remember, the range of potential, the electrical potential that you can impose on the system. Maksudnya kalau lagi besar window tu, lagi bagus lah. Maksudnya you letak kat mana pun, you fix any range of electric potential pun, still your electrode won't be damaged. Maksudnya you boleh buat eksperimen. And then because of these tunable properties means characteristics lah. You boleh buat macam-macam. You boleh modify the electrode, you boleh macam-macam, boleh sesuaikan dengan you punya sample. You can always cover them easily with mercury ataupun kalau you nak modify dengan any other films. And then you can modify it chemically or biologically easily. Its compatibility with organic solvents, you boleh juga guna organic solvent bila you menggunakan carbon-based electrode. You can always remove oxygen because when in the presence of oxygen, bila kita ada oxygen dalam sistem, oxygen is actually giving dia akan menyumbang kepada noise because oxygen is very reactive. So once your oxygen is let's say you ada oxygen dekat dalam beaker, that oxygen will diffuse. Dia akan masuk dalam you punya air yang oxygen tu akan duduk di atas surface you, on the surface of your electrode, and that will disturb the system in terms of in the form of noise. Dia akan kacau signal you. Patutnya signal tu datang daripada you punya target molecule sahaja. Tapi sebab you tak buang oxygen ni, dia akan kacau signal you. Mungkin dia akan keluarlah signal oxygen tu. Jadi one of the ways to minimize oxygen effect, kita gunakan, we have to remove it. We have to take it out. Macam mana cara nak buang oxygen daripada sistem? We use bubbling method. Bubbling means you masukkan nitrogen gas. You masukkan dalam beaker tu, macam tu, nanti macam blub-blub-blub, dia akan keluar udara tu. When you introduce nitrogen tu will force the oxygen to get out from the system. Seperti bila kita buat eksperimen, voltammetric experiment, biasanya kita akan bubbling sebab nak buang, nak minimizekan effect of oxygen. Okay, these are the pictures of working electrode. This is a commercial one. Ini yang memang dah siap lah, maksudnya kalau you tak nak buat sendiri, you boleh beli je working electrode. Ada macam-macam depending on the material of the electrode yang you nak beli tu. It could be mercury ke, you boleh beli glassy carbon ke, you beli graphite electrode ke, it's up to you. Harga dia berbeza lah. These are some of the working electrode yang you boleh gunakan. These ones are compatible with organic solvents. Sometimes you tak boleh buat eksperimen tu dalam ionic solvent ataupun ionic dalam electrolyte yang biasa, you boleh buat di dalam organic solvent. Okay, this is special cases. Again, and then okay, voltammetry ni ada dua, there are two types. Satu linear, the other one is cyclic. Kalau you ingat lagi tadi saya sebut tadi, voltammetric technique is about fixing a range of potential, the electrical potential. So let's say in this case, kalau you tengok from V1 to V2, V1 ni minus dia, let's say this is minus 0.1, V2 is plus 0.2 volts. Ya, ada dua. Maknanya daripada sini sampai ni kita panggil dia, this is what we call range. And then you measure, you run the experiment. So apa yang akan dapat? Actually, dalam you punya voltammogram, dalam graph yang you patut dapat, respond you adalah voltage versus current. Current ni yang you nak measure from anything, from the reaction that is coming from your system. Okay. Right. Again, Nernst equation. Contoh in this context, we talked about iron. Let's say iron 3 plus becoming 2 plus, and then you akan masukkan dalam ni lah. So this is the basic application yang you boleh gunakan untuk linear sweep voltammetry. So in LSB, linear sweep voltammetry ni, it depends on the electron transfer rates, and then the chemical reactivity of the electroactive species, and then the voltage scan rate. Okay, scan rate ni sebenarnya macam ni. It is the definition of scan rate is how fast you want to scan, you want to run the experiment. Let's say you dah fixkan potential window you from minus 0.1 to plus 0.1. So you nak scan kan, maknanya you nak you want to impose the electrical current. How fast do you want to impose it? Let's say 100 millivolt per second. So maknanya that's how you define scan rate. Okay, cyclic voltammetry pula sama je macam linear sweep voltammetry yang tadi tu. The only difference is that kalau linear tadi, you go from let's say from minus to positive kan. Let's say from minus 0.1 volt, you scan, you run the experiment up to plus 0.1, and then it goes back, dipatah balik. From plus 0.1, dipatah balik ke minus 0.1. That is why we call it cyclic voltammetry. So kalau you tengok kat sini, this is what you call voltammogram. This is the signal, this is the graph that you get from cyclic voltammetric technique. So let's say let's say you scan ataupun you run the experiment from minus 0.1. So it goes from here up here, and then you get this peak. Okay, this is what we call oxidation peak. Yeah, from here, daripada minus ke positif, normally akan berlaku oxidation. And then you patah balik. Sampai kat sini, plus 0.1 let's say, you patah balik, you scan lagi sekali sampai habis, sampai minus 0.1. Nanti you akan dapat in between there, you will see this reduction peak. This is where your sample is being reduced. This is where your sample is being oxidized. Oxidized means you are reducing electron. Electron akan keluar satu kan, ataupun dua ke tiga, depends on the reaction. So this is in overall lah. So this is a picture of a voltammogram, which was done at different scan rates. Maksudnya berapa laju you run eksperimen you. Contoh kalau you buat 50 millivolt per second, 50 ni, let's say 100 100, tengok warna biru muda ni. This is 100, and then kalau you lajukan lagi 100, you get the purple one, this one. So you akan dapat signal yang macam ni lah. This is the types of how it looks like. Okay, so bottom line, yang paling penting sekali, what are the most important points in photometric technique? Apa yang you akan analyze, macam mana cara you nak buat an analysis nanti. Inilah point-point dia. These are all the points that you will need to know and that you will apply when you want to interpret the data from the experiment that you will be conducting. So apa penting dia, ada 4 point kat sini yang penting sekali. The first thing, masih nak report apa semua nanti, the voltage separation. Okay, the voltage separation ni, contoh kalau untuk case ni kan, boleh tengok yang purple yang paling besar ni, the biggest one at 500 millivolt per second ni. Okay, this is the oxidation peak, right? So this is your reduction peak. So you measure the distance between peak ni dengan peak sini. So this is what we call potential difference. Perbezaan potential antara dua peak. So bila you measure tu, if you get more than 59 or 60 millivolts, okay, tak apa, saya explain kemudian. Okay, the difference is between one peak to another peak. If the difference between those two peaks, you get more than 60 millivolt, to be precise 59, tapi biasanya dalam 60. If you get more than 60 millivolt, then the reaction is said to be irreversible. Tak reversible lah. If you get less than 59 or 60 millivolt, it is called reversible, electrochemically reversible. Tak sama macam chemically reversible. In electrochemistry, we concern about the electron transfer rate. Macam mana lajunya you boleh transfer electron. And then the positions and positions of peak voltage do not alter as a function of voltage scan rate. Okay, kalau you tengok dekat dalam sini kan, position of your peaks, dia tak berubah, it doesn't change. Only the signal saja yang makin besar, tapi tempat dia sama, same points. Kalau dia berubah, kejap kat sini, kejap kat sana, then itu petanda maksudnya your reaction, the system is not reversible. It is irreversible. The third point, the ratio of the current, the peak current is equal to 1. Okay, peak current maksudnya, okay, let's say this is your oxidation peak current. You measure daripada sini kan, sini sampai sini peak current. This is your oxidation current, you measure, and then you take the ratio. If the ratio is not equal to 1, then automatically you know that this is irreversible reaction. Okay, fourth point. The peak currents are proportional to the square root of the scan rate. Nombor 4 ni, and D ni, actually you want to know whether this reaction is controlled by diffusion process. Remember the diffusion process? Maksudnya, the diffusion process is the one which is determining the electron transfer rate. So you akan buat satu graph, you plot x-axis ni adalah you punya the square root of the scan rate, and then on the y-axis you akan letak you punya values of peak current, then you plot. Kalau you dapat a straight line, then it is diffusion control. The reaction is controlled by diffusion process. Okay, this is just an example. There's the one on the left hand side here is reversible. This one on the right hand side irreversible. Sebab apa? You can see that the peaks are moving points, the moving positions. Yeah, dia berubah kan? Contohnya first scan warna biru in the blue color, and then bila you scan kali kedua, dia berubah pula. It shifted. There's a shift in terms of the position of your peak currents. So maksudnya you tahulah automatic yang sistem ni tak it is not electrochemically reversible. Ataupun you kata it is electrochemically irreversible. Okay, I think that's it for today's lecture. Saya harap you all semua fahamlah apa yang saya telah explain. Guys, you all okay? Are you with us? Are you with me? Still with me?
Yes, Doctor.
Okay.
Yes,
You guys tak tidur kan?
Tak.
Oh tak ya, asyik baik tak tidur. Kalau tak saya sorang-sorang dia cakap tak ada orang dengar. Okay. So ada apa-apa soalan? Anything that you are not clear? Ada yang macam saya rasa saya dah explain betul-betul ni nak bagi faham. You all faham tak? Wakarimashita kan Wakatta? Faham tak? You guys okay with today's lecture?
Yes, Doctor.
Okay, macam nak tanya faham ke tak faham in Japanese? Macam mana cakap? Wakarimashita ka? Wakarimashita ka? We always have that ka at the end of the sentence. Itu maksudnya that's a question mark. Wakarimashita ka? Kalau you faham, you kata hai, wakarimashita. Ya, I understood. Saya faham. So, saya tanya lagi sekali. Minasan means you guys, everyone. Minasan wakarimashita ka? So, you say, hai, wakarimashita. Ya, kami faham. Boleh tak? Sebut sikit. Wakarimashita ka?
Hai, wakarimashita.
Oh, okay. Cheers. Wakarimashita. Sebut sikit. Dengar lagi sekali. Hai, wakarimashita.
Hai,
Hai.
wakarimashita.
Hai, wakarimashita.
Okay. So, sekarang kalau macam tu, kyou wa kore dake. Hari ni itu saja. Kore dake. Kore dake means ini saja. Kore means this. Dake means only. Kore dake. Ini saja untuk hari ini. I'll see you again next week. So, take care everyone. Bye.
Okay, thank you, Doctor.
Bye.
Thank you, Doctor.
No problem. You're welcome.